Welcome everyone, and thank you for attending today's webinar. Let me present to you the agenda and welcome our speakers. This is a 90-minute webinar, and we have a great set of speakers to talk about telecom sustainability. So we'll have a short introduction from the leadership team of the NextG Alliance Green G Working Group, and then it will be followed by our keynote speaker with Nada Golmi from NIST. She's an NIST fellow. And then we will have Bhushan Yoshi from Ericsson, who will present the key highlights of our recently published Green G white paper with the path towards sustainable 6G. And it will be then followed by a panel. So we'll have a panel discussion that will be moderated by Carsten Baumann from Schneider Electric, and we will have 3 panelists. So the 3 panelists will be Andrea Bomholt from Mitch, then Clara Lee. The webinar will conclude with some closing remarks from Mikaela Judah, who is the co-vice chair of the Green G Working Group. We'll take a few questions, so please make sure to type your questions in the question window for consideration. With that, let me introduce to you briefly the topic. You must have seen recent scientific reports which have triggered awareness but also concern about the climate change situation and urgency. The current challenges of the global climate change and the need to reduce the carbon footprint emission are triggering the need for the next generation networks to look into and implement energy efficiency technologies. So our mission in the Green G Working Group is really to support this initiative and to help the industry really reduce the dependency on fossil fuel, but also use more renewable energies. The world has committed to keep the global temperature below 2 degrees and, if possible, below 1.5 degrees. So today, most countries, including the US, have signed up to that and are setting up some targets to reduce the major impact we can have on the global climate. Many countries, as I've said, but also operators, and today most, 2/3 actually of the operators are committing to net zero and have set a target to be carbon neutral by 2050 or even sooner, actually 2030 for some of them. This means that the Green G Working Group has the objective to really bring some innovation, some areas of improvements, but also to introduce some research topics to support the industry and to help the operators, the vendors, and everybody to really meet these sustainability goals and create a sustainable 6G, but also enable 6G to support the rest of the industry to become sustainable. With that, I would like to introduce Colleen Josephson, who is our co-vice chair of the Green G Working Group, and she will go into more details and present the objective of the Green G Working Group. So Colleen, the floor is yours.
Thank you so much, Marie-Paul. In 2020, the NextG Alliance formed to advance North American wireless technology leadership and emphasize technology commercialization, research and development, marketing, standardization, and market readiness. Shortly after, the Green G Working Group was created. The mission of the group is to position North America as the global leader in environmental sustainability of the next generation of mobile networks and to reduce NextG energy consumption and the environmental impact. Tackling sustainability is a challenge that requires the working group to think beyond renewable energy. While energy consumption is a very important aspect of sustainable practices, we also need to consider the ICT sector's overall environmental impact, including land and water use, waste handling, circular economies, as well as recycling and sourcing of the materials that are used for electronics manufacturing. The Green G Working Group consists of dozens of members and contributing companies. It's chaired by Marie Paul, who you just heard from, of HPE, myself, Colleen Josephson of VMware, and Mikaela Judah of Microsoft. The group spent most of 2021 crafting its first white paper. As we mentioned earlier, it's titled The Next G Alliance's Green G, The Path Towards Sustainable 6G. It was released in January of this past year. Today's event will review the recent white paper and the findings, and we'll talk about the spirit of the white paper, starting with our keynote speaker, Nada Golmi, an NSIT fellow. Dr. Golmi received her PhD in computer science from the University of Maryland at College Park. In 1993, she has been an active research engineer at the National Institute of Standards and Technology. From 2014 to 2022, she served as the chief of the Wireless Networks Division in the Communications Technology Laboratory. She is an IEEE and NIST fellow. Her research in media access control protocols for wireless networks has led to over 200 technical papers presented at professional conferences and journals, and contributed to international standard organizations and industry-led consortia. She is also the author of Coexistence in Wireless Networks, Challenges and System-Level Solutions in the Unlicensed Band, which is produced by Cambridge University Press. She leads several projects related to the modeling and evaluation of future generation wireless systems and protocols, and serves as the Next G Channel Model Alliance Chair. Now, with that, I am very pleased to turn over the floor to our distinguished Nada for her keynote.
Thank you very much, Colleen, for this introduction. Thank you, the organizers, for giving me the opportunity to participate in this conversation on Green G and the path towards a sustainable 6G. Today, I will discuss some of the sustainability challenges, as mentioned by Marie-Paul and Colleen, and touch on some of the opportunities we have in our efforts in supporting a more sustainable 6G going forward. Next slide, please. So for those of you who are not familiar with NIST, we are part of the US Department of Commerce. I am from the Communications Technology Laboratory. As a National Measurement Institute, our focus at NIST has been on high quality measurements, data, and research supporting US innovation, industrial competitiveness, and standard development. Next slide, please. So the vision for NextG, and everywhere we look, there are lots of visions being put out there for beyond 5G and 6G, but I suspect that we will continue to handle huge amount of data at light speeds and very low latencies. As a result, the devices and systems that surround us will respond to each other and to us in the blink of an eye. What we're witnessing is a true transformation in many sectors and domains, from smart cities to telehealth to robotics, agriculture, manufacturing, and the like. So this transformation started in 5G has been fueled by combining the data from many devices, IoT, and connectivity with 5G. There are obviously lots of implications and huge impact on how we experience the world and the environment we're in. So with data, connectivity, and AI, we're able to achieve better automation, better control, and intelligence. So the list of verticals and applications benefiting from these advances is very long, and this is by no means an exhaustive list. So from industrial applications, the so-called Industry 4.0, automated factories, recyclable infrastructure, mobile robots, remote control machines, reconfigurable production lines, collaborative robotics, smart manufacturing, media and entertainment, tactile internet, immersive media, AR, VR, 360, 6 degrees of freedom, health, financial services, construction. I mean, you get the point. So the number of IoT devices, it is expected, it is predicted that it could surpass 125 billion by 2030. So the number of bits processed per year continues to grow. We're still not there yet. So for example, while we're currently possible to transmit all world stored data in less than 1 year, it is predicted that it will require at least 20 years to do the same transmission, the transmission of all the stored data in 2040. So you get the point. So next slide, please. So the impact on the planet for the industrialization and hyperconnectivity is real. Not sure if any of you had the opportunity to check out some of the visualizations that are available on the NASA website. It's truly eye-opening. And for example, here in 1921 on the left, in 2022 on the right, the global temperature. So you know, in the last 100 years, you know, we gained, you know, some increase in temperature. Next slide, please. So the realization that the era of free and abundant energy without any constraints, it's sort of behind us. So we're going to operate from now on in an energy scarcity regime, and we have to look for ways to make it all work or be sustainable. So if we have a commitment, as Pauline mentioned, to reduce the global surface temperature to no more than 2 degrees by 2050, and we are at 1.2, we probably don't have much time to waste, right? We have to get to work and work on it. So the pledge for the ICT industry is to reach the net zero greenhouse emission by 2050. Next slide, please. So while most communications folks like me, and perhaps some of you, are focused on spectrum for wireless connectivity, and the latest innovations to increase coverage and bandwidth, it is no longer possible to ignore the energy footprint and the impact of this hyperconnectivity and the data overconsumption on the environment amidst increased awareness of climate change, repeated call to action to slow down the global warming. So let's look at some of these numbers. And this slide is busy, I apologize for that. So from an energy consumption point of view, the total energy consumption for computing is doubling every 3 years. The ICT industry currently consumes 5 to 9%, but this may rise up to 20% by 2030. Telecommunications, more specifically, consumes between 2 to 3% of the global electricity supply. So electricity cost represents 1/3 of a carrier's average operational cost. The RAN consumes about 70 to 80% of the energy in mobile networks. So we're told the power amplifiers are the main culprit there. So at the same time, we're witnessing improved energy efficiency, right? So the chip level energy per 1-bit transition in processors is decreasing. If we look at the evolution from 4G to 5G, we have 16 times more throughput, 5 times more bandwidth, extended battery life, target is greater than 10 years. However, we have 4 times more power consumption because we have also 2 to 3 times more and smaller cells. So the energy production is only growing linearly by 2% every year. So we can see demand is outpacing advances in Moore's law as we reach the fundamental physical limits. Next slide, please. So there are several dilemmas for NextG. What we are called to expand, the network infrastructure while reducing the amount of traffic going through it. Obviously, we need to increase the energy efficiency. So the technological innovations are needed to improve energy efficiency, as we need to make sure that these innovations are not offset by overconsumption. So while our goal is to connect the next billion, to bridge the digital divide, that's the ultimate goal for development, we also want to reduce overconsumption and raise consumer awareness for the planet. So there's one interesting point here about the technological advances in energy efficiency. If there's a tendency to increase consumption when things are more efficient and cheaper. So we should watch for this so-called rebound effect. By making technology and Next-G more available and affordable, it will use more, and thus it will consume more energy. So mind you that with smart transport, smart buildings, we're able to reduce 15% of the greenhouse gas emission. So connectivity is not bad. Hence another paradox. So in fact, the mobile sector has a key role to play by increasing connectivity, improving efficiency, and impacting behavior change. Mobile network enabled technologies are helping avoid emissions. So there are many reports that are written. There's cite one by the GSMA in 2018 that looks at the estimated energy, the impact of mobile communications in terms of millions of tons of carbon oxide emission equivalent. So it's about 0.4% of the global emissions. However, these mobile networks help avoid emissions because they enable other sectors. So, and it's a positive impact of tenfold. So connectivity is good and could be part of the enablement, part of the change and the positive impact. Next slide, please. So obviously there are lots of challenges, just a a very quick overview here, but there are also numerous opportunities for R&D. So here are a few topics that come to mind, and this is by no means an exhaustive list. Starting with energy consumption models. So a few decades ago, these were very simplistic and lacked real measurements or data. Today, we have more sophisticated, more elaborate energy models for many of the network components, the RAN elements, the edge, the core. Obviously, energy-aware everything from network planning to resource management to directional antenna to reconfigurable intelligent surfaces to the use of renewables. You'll notice of most of these areas have in common is intelligence, or the use of data and machine learning for optimization. Next slide, please. So AI-aided methods are able to deal with the massive data generated for many optimization problems over large sets of variables, or to come up with approximations for computationally expensive functions. Deep reinforcement learning can achieve model-free control by interacting with the environment. This shift from model-oriented to data-oriented avoids the introduction of explicit models. So the question, though, is to ask, how would we save energy if we're going to do more computationally expensive machine learning? It is obvious that the benefits of machine learning come at a cost. We suspect that computational complexity can be reduced by replacing the optimization algorithm with online inferences of a learning model with a trained offline, etc. So, however, the computational complexity and the cost of deep learning cannot be ignored, and that is, again, a research opportunity. So I believe what's missing is putting all of these models, this knowledge together while exploring simpler methods. Next slide, please. So in order to innovate, optimize, we need to measure. At least we at an NMI like NIST, we strongly believe that. So measurements data today is critical in all aspects of the design, development, and deployment of communication systems. So that is reflected in our program that combines measurements, modeling, and the use of AI. We are also curating and validating the data and making it available and using it to develop models or train AI. As an example, we invest in the design and development of world-class channel sounders to accurately characterize wireless propagation in the higher frequency band, those that are in use today in the US for some 5G deployments. With the measurement data, we develop models. Models based on measurement validate theoretical assumptions and mathematical models. So they're used by the research community, but also by industry to design next generation circuit systems and provide the standard developing organizations the data to develop specifications. So they're also used by service providers and operators to deploy next generation systems. Next slide, please. Few additional examples of measurement data for AI and AI modeling. So NIST curates and disseminates RF waveform and propagation measurement data and models. For example, the radar waveform collected in the CBRS band, and they are used today by industry to develop better sensing techniques. As I mentioned, the millimeter wave channel measurements to develop models using AI for various environments. We also look at measurement data for human sensing. So these are some examples of the current work that we have. Next slide, please. So we also combine this data with system simulation. Oftentimes, each part of the system is modeled and simulated separately, and interfaces are built to allow the abstractions to reduce complexity. However, in some cases, low level and measurements are needed in order to provide more accuracy. So we developed in collaborations with others these tools. One of them is an example is the QD tool suite for modeling Wi-Fi. So this is based on NS3. It's available on GitHub and includes many users. So next slide, please. So the research community needs measurements and data sets for AI and machine learning. Operators have been using their data for years. So a couple of options include, NSF-sponsored testbeds. NIST put out measurement data. In some cases, simulations can be used as well. In fact, in 2015, we founded the NextG Channel Model Alliance, which is a consortium representing 184 organizations worldwide today to share propagation measurements and data for methods for obtaining them. So we're able to host the data we generate, but also host our collaborators' data. Next slide, please. So additional measurement data from NIST, many test beds and state-of-the-art facilities and tools for simulation and evaluation are also available for public download. Next slide, please. So we also suspect that it's becoming impossible for single organizations to do all of it alone. So we have several models of partnerships and collaborations at NIST. The one such model is the National Advanced Spectrum Coordination Test Network, the so-called NASTN, which is hosted at NIST and provides access to a national network of federal, academic, and commercial test facilities to perform spectrum research to the public safety. We have the Public Safety Communications Innovation Accelerator Program, which is working with FirstNet and first responders to bring an innovation to day-to-day first responders operation. And we have public-private partnerships like the NextG Channel Model Alliance that I mentioned, but also more recently we engaged with NSF and the DoD and industry, about 9 companies. Some of them are represented here today in the so-called RINGS program, which is a partnership that provides funding over 3 years and will be kicked off, launched very soon with awards very soon to look at collaborative projects across the community. Next slide, please. So also this past year, we have partnered with the National Science Foundation and the Department of Defense in convening a joint working group to identify next generation wireless research and development R&D gaps. Some of you may have been contacted already. This effort is building on the findings of a report that we published in 2018. The team, invites interested parties to participate in a series of virtual workshops to identify long-term, 10 years plus out R&D gaps not already being researched by industry or academic organizations to inform future R&D planning activities. Obviously, sustainability is one of the topics that we're gonna perhaps discuss. So this is gonna start in the spring of 2022. Actually, on April 6th, we have our kickoff meeting, and we'll convene, a series of workshops and people can participate. So that's, I believe, is the end of my remarks. So thank you very much for the opportunity. And I'll be glad to learn and engage more with all of you as we go forward. Thank you.
Thank you very much, Nada, for the engaging talk. And now I'd like to introduce our subject matter expert, Bhushan Joshi. Bhushan is the head of sustainability and corporate responsibility for Ericsson in the market of North America. He's focused on understanding key sustainability challenges faced by telecom operators and leveraging Ericsson solutions to help operators achieve their sustainability goals. He advocates for the role of information and communication technology, ICT, in helping other industries take exponential climate action. Bhushan has been in the energy management and corporate sustainability domain for the past 15 years. He also has an MBA in sustainable business practices from Dunsk University in Pittsburgh, Pennsylvania. And with that, Bhushan, I welcome you to take it away.
Thank you so much, Colleen. I really appreciate this opportunity to talk about this Green working group white paper that was released earlier this year. So if you could go to the next slide. We looked at a lot of things when this white paper came out, and the slide that you see now talks about some of the key areas that we assessed as part of this white paper. We looked at things around, the structure of a typical mobile network. What does 4G look like in comparison to 5G? What are the future traffic growth impacts on power consumption? What does sustainability look like in networks and in data centers and the various components within it? So you will find this report will provide you a lot of good information on what does sustainability mean for all components in the network, including the RAN, the data center, but also devices, and also looking at not just the actual network, but looking at the overall value chain, the hardware, the manufacturing of these devices. And really, again, the objective is to provide some really good guidance in terms of how should we think about next generation mobile networks as sustainability enablers, kind of going back to what Nada was talking about, the potential that the ICT sector has, and really how can North America be the leader when it comes to sustainability in the next G. So if you go to the next slide, here's kind of my rough agenda for the time that we have together. So I'll talk a little bit about the climate change, the biggest challenge that we're facing as humankind, the role that the ICT industry is doing in order to rise to this challenge. What are some of the key sustainability aspects that we should consider while we think about sustainability? Because sustainability is not just emissions and energy usage. It's a much broader topic. And then finally, decarbonization, the potential of the ICT sector to enable decarbonization of industries. And then we'll talk about some of the recommendations and maybe some call to actions at the end as you think about this white paper. So if you go to the next slide, I wanted to kind of start by kind of positioning how big this challenge is. So the most recent UN report on climate change has been called as a code red for humanity. According to NASA, the past 8 years have been one of the most hottest years since we started keeping records since the 1800s. The UN report also indicates that we have already warmed the planet 1.1 degrees Celsius above the pre-industrial levels. We're starting to see some of these impacts of climate change already in our communities. This is not something that's happening in the future, it's happening now. In Texas, we had this massive storm a couple of years ago, 2 years ago, I think, wiped out, the grid and cost about 100 lives actually, and $130 billion in economic damage. So, when you look at that, when you look at the commitments that have been made at the climate conference in Glasgow last year, they're not enough. They are only they're going to lead to a world that's 2.7 degrees Celsius warmer, from the pre-industrial levels. And so some level of climate change and climate impacts are already locked in. But time is not, we haven't lost time yet. There's still the opportunity for us to correct and make sure that we reach the goals of the Paris Climate Accord. And to do that, all sectors of the economy, including the ICT sector, need to decarbonize. So if you go to the next slide, what we need to do is we need to cut emissions by half each decade, and then we reach net zero by 2050. So what is net zero? Net zero is a state where emissions to the atmosphere, carbon emissions or greenhouse gas emissions to the atmosphere, are balanced by the removal of emissions from the atmosphere. So it's reaching that balance. So to do that, what we need to do is reduce emissions through energy efficiency, through design or adoption of renewable energy sources to power ICT networks. All of those things apply. But at the same time, what we also need to do is we need to increase the nature-based sinks. So, forest and new solutions that we can come up that will allow us to fix the atmospheric carbon in a way that would take that out of the atmosphere and bring our global climate back into the balance where it needs to be in order for us to have a successful and thriving life. The good news is that while the first 50% reduction that needs to happen this decade is the biggest reduction that needs to happen, there are solutions that are available. So what we need to do is we need to collaborate with our partners within our ecosystems, within our value chains, and really drive climate action and accelerate this, because the longer we wait, the bigger the change we need to make and the larger potential disruption it could have to the global economy. So if you go to the next slide, climate action essentially is not just limited to what you can do within the emissions that are in your direct operational control, right? Just doing that is clearly not going to be enough. So in the white paper, we talk about the importance of addressing indirect emissions, specifically in products and technology development. So for a lot of OEM companies, emissions that come from the use of the products that we sell are some of the biggest sources of greenhouse gas emissions. So innovating to make sure that we're developing products that are more and more energy efficient, allow the reduction of energy usage and carbon emissions when they're in their use stage is very important. The second, I think, important thing is to invest in sustainable supply chains. So, we need to work with our supply chain partners and make commitments, to work with our suppliers to cut emissions by half again this decade. But just making these demands isn't going to be enough. We need to provide them resources, because some of the value chain, some of the suppliers and partners that we work with are not big multinational companies. They're small and medium-sized businesses who needs tools, and they need tools and services in order for them to establish these robust climate strategies. And then finally, transitioning to a circular economy approach, designing hardware and components that can be recycled, that can be reused, that can be made from sustainable materials. So you can read about all of this in the white paper. And again, like I said, we need to take this whole value chain approach. But what's really encouraging, and if you go to the next slide, is to see that the whole ICT industry is aligned behind a science-based pathway to reach net zero emissions by 2050. And in the report, we kind of talk about, what does this pathway look like? So this pathway looks like, so the pathway is basically cut emissions by half each decade. So by 2030, the goal is to halve emissions by 2030 compared to a 2015 baseline. And that's what are called science-based targets. So the science-based targets are targets that are aligned with climate science and provide each sector what it needs to do in order to decarbonize at the rate and scale at which it needs to decarbonize. And then the long-term goal is to reach net zero by 2050 or earlier, if possible. And this again has been defined by the ITU. So, the really good thing about this is that these pathways have been developed in consultation with the ITU, the GSMA, GESI, mobile network operators around the world, and companies like Ericsson who provide solutions and services in this aspect as well. We've seen that a lot of mobile network operators in North America have already made commitments. They already have science-based targets. They have set goals to become carbon neutral. So, it's encouraging to see that there is this progress that's happening, but there's a long way that we need to go. The US is also now in the part of the Paris Climate Accord. We have goals to reach 50% reduction, and then have a carbon-free or pollution-free power sector by 2035 and a net zero economy no later than 2050. So we have all of this wind behind our sails, so to speak. So it's time now for us to kind of double down and really help accelerate climate action. So if you go to the next slide, let's take kind of a quick look back, and Nada was talking about this as well, is that, when you look at the last 10 years since the introduction of 4G, traffic has grown exponentially. Traffic has grown about 300 times, driven by a lot of subscribers coming on board, also really increasing population coverage. And service providers' energy consumption compared to that exponential increase in data traffic has only risen by about 64%. So, you have to kind of think about that and think about the success that we as an industry have been able to drive in keeping emissions low and providing services that about 70% of the global population uses. So every single, everyone is using these services every single day to make phone calls or do digital banking. So there's a lot of reach that our sector provides. And while we have taken, while we have done a great job, delivering less with more, what we also need to do is that we need to make sure that we continue to innovate. So when we look forward about, and if you go to the next slide, when you look at, we look at in this white paper, we note that the broader ICT industry consumes about 2 to 3% of the global power consumption. But with the rapid growth in digitalization, as our lives become more and more digitalized, I do more with digital every year than I did the year before, reducing impacts of power consumption is going to be key. More specifically in North America, mobile data traffic is expected to grow at a compounded annual growth rate of 26% from 2021 to 2027, and 5G is going to be ubiquitous. It's going to be 90% penetration. So, with the deployment of each new generation of mobile technology, there have been concerns about increasing power consumption, and with 5G and 6G, that's not going to be an exception. And just like how 5G standard is designed to be more energy efficient, in the white paper, we talk about why is it important to make sure that 6G and the ecosystem for 6G is designed with energy efficiency and performance in mind. So when you think about that, the goals that we need to achieve, it's not just enough to, we need to take a holistic approach. And that really, again, if you go to the next slide, starts with understanding the usage in the mobile networks. So in the white paper, we talk about the distribution of energy consumption across various components within the 4G and 5G network, and you will see that the RAN consumption for 5G has reduced, but it's still over 50%. The other trend that we note in the paper is that we see that the data center consumption has increased as more functions and more services move to the cloud. So there have been a lot of improvements again, but I think what we need to do, and we talk about this in the white paper, is that as the world digitizes and we move towards 6G, we need to make sure that we take a very holistic approach, towards this. So if you go to the next slide, it's important for us to make sure that we look at the whole network. So this really starts with modernization, preparing the network. So in the white paper, we talk about why is it important to do timely modernization, because it allows us to minimize the power consumption in immediate. So in the white paper, we note that we've seen some estimates that just modernizing from 4G to 5G could save up to 90%, in energy needed per bit. But we also need to make sure that we continue on this trend when it comes to 6G, and we do everything we can to make sure that we're able to do more with less, so to speak. And we need to take advantage of cell sleep mode functionality, energy saving software solutions. Those need to be strengthened in 6G as well. And then really thinking about how we deploy networks, deploy with the right equipment in the right place. And then, we have AI and machine learning and all of these technologies that are now coming on, where we can really get a better view of how the network and the ecosystem functions and really drive efficiency, do things like reduce truck rolls that need to go out and fix equipment, because those are also emissions. So while RAN is the major source of emissions, and if you go to the next slide, in the white paper, we talk about the importance of looking at the entire network. So we look at, different technologies that we need to bring to bear, harvesting energy, enhanced sleep mode functionality, designing materials and batteries that reduce the impact of water consumption. We look at technologies like energy dissipation, and in general, we need to do more research on what does it mean to have sustainable materials, how can we enable more resource efficiency, how can we enable more waste and recycling. So we need to look at the entire ecosystem. But really, I think all of this, if you go to the next slide, starts with, the fact that sustainability is not just about emissions, it's more than emissions, right? So we need to talk about, in the paper, we talk about transitioning from a linear source of a linear economic approach where we kind of take, make, and dispose towards more of a circular approach that is cradle to cradle. And I think it's most, it's inspirational to kind of look at leaders in this space. And one of my favorite quotes is from Bill McDonough, who is one of the pioneers of circular design. And Bill says, design is the first signal of human intention. So we need to take the circular economy as a part of our intention. And we need to, that is what we need in order to drive this transformation to a more circular economy. So in the white paper, again, we're talking about, what is the importance of adopting this life cycle assessment, the LCAs, as people who know the terminology will recognize. What LCAs do is that they provide you a true understanding of the overall impacts of a product's entire life cycle. And once you have that understanding, and these aspects include not just emissions, but water, material use, you are then able to design your products and in a way that they can reduce the environmental impact in all stages of its life cycle. So again, it's really important for us as the world digitizes. We need to take into account, the demand for materials is going to increase. So we need to develop ways in which we could recycle, reuse materials more efficiently, right? And make sure that the impacts caused by the ICT industry to land and to air and to water are minimized. And we design a more circular, a cradle to cradle type system. But if you go to the next slide, I think we've talked about this in some way or form before. I think digitalization is truly an exponential technology. We account for about 1.4% of the global emissions, but the potential is huge. And in this white paper, we talk about the fact that the ICT sector can have up to 15% reduction or enable up to 15% reduction in overall global emissions just in this decade. So that first 50% reduction, which is the biggest reduction that we need to make, the ICT sector, the existing technologies in the ICT sector can enable up to 15% reduction. So the ICT sector really is a great return on investment when it comes to climate action, right? We can enable a lot of different things, and that's using existing technology. 6G, when we have 6G technologies, we need to make sure that those technologies continue to provide, provide the decarbonization impact that current technologies provide. Because once the 50% reduction is over this decade, we still need to cut emissions by half again, and 6G and 6G technologies need to be available and need to be designed in a way that they will continue to enable that. So these are some of the examples in which we could kind of drive emissions down. The biggest impact that the ICT sector can have, on different sectors or key sectors are the energy sector and the transportation sector. And I'll kind of quickly go through this because I'm not sure if I am track with time or I'm running behind. But if you go to the next slide, real quick, we'll talk about the energy sector. And I think this sector is important because we're tied very closely, the ICT sector with the power sector. ICT or the energy or the energy production sector accounts for about 66% of the global greenhouse gas emissions. And if we talk about reaching the net goals of the Paris Climate Accord, then up to 85% of our power needs to come from renewable sources. So when you think about all of these renewable resources kind of coming online, some are variable. Wind doesn't blow all the time and the sun doesn't shine all the time. We need to move from a grid that we have today to a grid that's digitized, decarbonized, and decentralized. And the digitized part is key, because with technologies that the ICT sector can provide, we can give the grid operators some of the solutions that they need in order to make sure that the balance in the grid exists, that they're able to bring on these multiple sources, provide us the reliable power that we need, and continue to service our economy. So we'll skip the next slide. That's about manufacturing. But again, manufacturing is also a big source of emissions, and we need to make sure that we can kind of look at that. But here's some recommendations now for you. So in the white paper, we talk about key recommendations for the ICT sector to think about. We need to make sure that we set science-based targets, make commitments to reach net zero at latest by 2050. We need to invest in sustainable supply chains. We need to transition towards a circular economy, which is important. And with circular economy, all sorts of better environmental outcomes come into play. We need to move towards more renewables, and you already see that the technology sector is one of the largest corporate purchasers of renewable energy within the United States. And then really focus on deploying and maximizing the decarbonization potential of connectivity within this decade and with NextG in the decades that come after that. So there's a lot of potential for us, and in which the ICT sector can drive big climate impacts and also change the way we run. And really, the call to action for all of you who are who have joined us in this webinar is to really go check out this paper, download it, read it. It's going to give you some really good insights that you can take back to your companies or your organizations and help drive climate action at scale. So thank you for this opportunity. Colleen, over to you.
Thank you so much, Bhushan. I'm pleased to let everyone know that we do have some time for a few questions. Please submit them via the question section of the webinar. And while we're waiting for some of our audience members to type out their thoughts, I'll get us started with a question of my own. So you mentioned embodied emissions and the somewhat surprising statistic that a majority of an organization's emissions frequently might be coming from the carbon footprint of manufactured electronics. So can you tell us about some of the latest work and initiatives happening in our industry to increase both the rate and effectiveness of electronics recycling or other measures being taken to address indirect emissions?
Yeah. So I think two things, Colleen, and I'll kind of speak about this from my company's perspective, and then maybe the sector perspective as well. I think when you look at the life cycle assessment, when we do these life cycle assessments, you kind of clearly see the data, right? The emissions from use of products are the largest source of emissions for us at Ericsson. Our own company footprint is relatively smaller. So when you think about how that informs the strategy for climate change and climate action and sustainability within my company, we've focused on developing products that are more energy efficient. We have goals to make a 5G portfolio 10x more efficient than the one before that. So across the industry, I see this being adopted. I see the development of more and more energy efficient devices, and that we can put in front of our service providers, right, to operate their networks efficiently, reduce power consumption. And then on the waste and recycling side, I think that e-waste is a challenge, right? We every year we use more electronics. Everybody, I think, on the phone probably has one or two cell phones in their drawer somewhere, right? And this problem is only bigger when it comes to commercial applications. We're seeing a lot of companies, providing opportunities for people to recycle devices with them. Most of the MNOs that we have product recycling, at their stores, and then companies like Ericsson, and we provide that opportunity to our customers to recycle at no cost. But we need to develop a more broader ecosystem so that we capture everything that we're putting out there. Equipment that gets recycled, reused, and repurposed in a different market, because upcycling has a bigger impact environmentally than recycling. So, some thoughts, Colleen. I hope that answered your question.
Yes, thank you. Thank you very much. And it looks like we do have some audience questions. The first one I'll ask is 4G to 5G, it consumes 4 times the energy. Why is I think the question is, why is the energy of 5G why has that energy consumption increased? And are we going to see similar trends in the transition from 5G to 6G, and how do we stop it?
Yeah, so I think it's a nuanced question to answer, right? And there's a bunch of perspectives here. So I think we have to kind of look at a couple of things here. So the first thing that I think we need to look at is that 5G is designed to be more energy efficient per bit, right? So we're providing more with less. It's designed in a way that it can go to sleep mode, right? It has the potential. It has more opportunities with 5G to go into sleep mode than we did with 4G. But at the same time, we're deploying more, right? In our mobility report, we talk about how, while traffic has gone up, energy usage has gone up relatively little, right? So it's more, there's a more direct correlation with deployment of hardware and bands that's really driving up power consumption. So, so we need to kind of keep all of those things in mind. And we need to take this, we need to take this holistic approach. It's not just about hardware, but it's also about, maximizing the cell sleep mode functionalities within 5G. And then I think we need to kind of make sure that some of these designs, the 5G and how it's designed to be energy efficient, we make sure that we include that in 6G as well. So when the next generation comes along, right, we have energy efficiency designed into it. But at the end of the day, if we're just using something more, right, and we're deploying it more ubiquitously, we're going to see power increase, right? And how much that increases depends on how we deploy and how we leverage some of the solutions that we have available to reduce that power consumption.
Thank you. Thank you very much. So we've got a couple more. One's a great one, actually, is will will our working group be working on effective means to help educate our community?
That's a good one, Colleen. Maybe that's something we need to talk about in our working group. But one quick thought from me, I think if you look at the ITU guidance on net zero for the ICT sector, they talk about carbon emission reduction. They talk about 3 strategies. One is reducing emissions, transitioning to renewables, and then actually educating consumers about carbon conscious choices. So it's actually one of the 3 steps that they state in the standard. So definitely something to think about. We can all make this happen if we work collectively. We need to prioritize this as a society, in order for us to achieve some of these big objectives that we need to achieve. I don't know if you want to add anything to that, Colleen.
Yeah, and I thought it was a great question. And I guess one thing is, we are running this webinar. That's obviously just a first step, but we do want to continue to do that in the future. Some of our members have written blog posts, kind of putting their own perspective on the work that we've been doing. If any of the audience members have suggestions on what they want to see as far as education and outreach, we welcome them to put that in the chat, or maybe join a meeting sometime, join the Alliance and provide feedback there. But it's a very good point. We have another one. So one audience member asks, what are all the solutions being discussed for reducing energy consumption at the RAN? They add that limiting power requirements despite increasing throughput consumption and providing secure connections is going to be a challenge.
Yeah, so I think that, I'm trying to kind of understand the question. Yeah, so I think that, there are different things that we're thinking about, right? Designing, like I said, more efficient equipment, I think, is the first step. But it is also, again, like taking this whole system approach, right? Not just looking at the hardware, but looking at, how we operate the hardware. Are we dimensioning it correctly? Are we over-dimensioning things? So it's not just one solution. I think it's a range of different solutions that we need to bring together. You need to find a way to balance this, true, right? Like, I mean, with cell sleep mode, how aggressive do you want to get? So things like that, I think, need to be balanced. But I think it's not just like one thing, right, where you're doing more efficient hardware. Is looking at, a basket of solutions that you can bring to bear, to address this challenge and make sure that you provide that connectivity and the connections and the throughput that you need. So the challenge really is how can you maximize power reduction without impacting performance. So yeah, it is going to be a challenge, but there are solutions that we have that we can start deploying right now. And we need to make sure that we think about that with next year as well, right? Because that's what we need to go towards.
Great, thank you so much. We do have a lot of questions, but unfortunately we are running a little short on time. So I'm going to wrap it up there. And thank you very much for your talk and answering questions. I enjoyed it greatly. And now let's move on to our panel discussion, which will be moderated by Karsten Baumann, who is the Director of Strategic Initiatives and a Solution Architect of the Secure Power Division and Strategy and Sustainability from Schneider Electric. Hi, Karsten.
Well, thank you so much, Colleen. What a fantastic kind of webinar so far. And I really appreciate all the questions that are already coming in. And I would encourage everyone to please keep coming them so we have an ability to kind of like explore those, and help us to move forward into our efforts as we go on. So yeah, I would like to thank our panelists, for providing their thought leadership here today. And what we're going to do to set the stage for our panel discussion, we will not be doing a deep dive into the technical elements as it relates to 6G. Instead, we're aiming to explore what kind of opportunities and challenges are associated with sustainability and innovation, specifically innovation such as 6G. And as we heard from our previous speakers, the white paper, Green G, the path towards sustainable 6G, I think it lays a great foundation about the different elements of 6G deployment and their sustainability impact. So during our panel today, what we want to do in the next 25-30 minutes is to explore the roles and the responsibilities of organizations and society at large. So we want to talk about, what kind of influence the digital economy has in terms of sustainability, the race to net zero, the circular economy, and then explore as well the entire ecosystem as it relates to organizations, companies, consumers, and perhaps as well the role of the government. So with that, I would like to introduce you to Andrea Bohmholt. Andrea Bohmholt, she's a principal environmental economist at MITRE Corporation. She has led sustainability teams on projects ranging from 5 million to over 5 billion. Noteworthy was the recent Envision Platinum Sustainability Award for the Gordie Howe International Bridge. She's a technical practice leader for sustainability return on investment analysis. She is a contributor to the report that defines carbon neutral and authored a book on how to reduce our carbon footprint. She's currently leading a research and development effort on corporate sustainability for MITRE. Welcome, Andrea.
Thank you.
Then we have Dr. Amy Zellman. Welcome, Amy. She is an internationally recognized futurist and strategist focusing on information technology, society, and governance. She is the founder of Presigned and is a professor of strategic foresight in the Culture, Communications, and Technology program at Georgetown University. In 2015, the Huffington Post called her one of the world's 7 top futurists, and she was cited in Forbes as one of the world's 50 leading female futurists in 2020. She also served as the CEO and president of the World Future Society and is the chair of information integration at the US National War College. She earned her doctorate from the Department of Middle Eastern and Islamic Studies at New York University. Welcome, Amy. All right, and then we have Dr. Clara Lee. She is a senior principal engineer with the Next Generation and Standards Division of Intel. Since joined in Intel in 2020, Clara has been working on LTE and 5G communication systems design and standardization in the area of air interface, radio access network, core network, and edge computing. Clara is currently leading 6G technology development in Intel and serves as the Technology Steering Committee Chair in ION-GF. Clara likes to travel and explore cultural heritage. So welcome, Clara.
Thank you, Christian.
All right, so let's start with Amy. Amy, you are, Andrea, I'm sorry, I'm making a mistake here. Andrea, you are an environmental economist. So help us to understand, what do you do every day and who are your clients?
Sure, and can you hear me okay?
Yes.
Okay, great. So environmental economics is a subset of economics that's really focused on the interactions between human activity and the natural environment. So as an environmental economist, most of my work has been in evaluation of non-market goods and services, such as ecosystem services, greenhouse gases, and air quality. Monetization of the economic, social, and environmental benefits and consequences, or the triple bottom line, of an investment or action can provide a comparison of disparate impacts using a common metric, money. Environmental economists typically use the benefit cost analysis framework for these types of analyses, and I'm working on how to better incorporate the consideration of social equity into that decision-making framework. So I've worked for the federal government, local, state government, as well as private companies doing this type of work.
And Andrea, do you see that this is, like a growing field, or how has this evolved over the last 5 years and today and tomorrow?
So really, environmental economics has become more mainstream starting 4 years ago when Reagan signed an executive order requiring benefit cost analysis for any notable government actions. Before that, it was used for water resources projects dating back to like the 30s and 40s. So it's been around a long time, but as we start to be more aware and considerate of the environment, society, and what the impacts can be of our actions, I think it becomes more important to be able to understand how we can evaluate those things in a way that we all understand, using a common metric. If you're looking at investing something, you want to look at what are the trade-offs and what are the benefits of those investments so you can prioritize them.
Excellent, thank you, Andrea. Dr. Thelman, you have a whole range of different roles and responsibilities, and I'm fascinated by your role as a futurist. It's almost like you have the magic ball, look at the, what's happening. Help us to understand, what are your roles and responsibilities today, and what excites you the most?
Yeah, so I have to tell you that futurists hate the magic 8-ball or the magic ball comparison. They get very upset. I don't. I think it's cool, but yeah, the role of a futurist, which is an odd title, is to help people and help organizations when they recognize that the future is complex and holds uncertainty, and to help them use information, some of which is emergent and some of which is well established, like that about climate change, to develop scenarios about what the future might hold. And in those scenarios lie risks and also opportunities that they might not have noticed before, or at least taken advantage of, or work to mitigate. So that's my bread and butter these days, as I work with a variety of clients and across government, military, and the private sector, and some nonprofits. When they start to have questions, they say, the future is complex. Somebody asked me the other day about looking into research around extreme longevity, for example, just to give you an example. I wanted to share one project with you because I actually think it ties back to this work. So one of my clients right now is a nonprofit that works with the state courts. Nothing to do with technology, nothing to do with ICT, and their questions have to do with the future of justice, and the delivery of justice. But like every other workplace, they are thinking about how to model sort of what they do, justice and equity, but they're also thinking about their workplace, how to become more data-driven, what their real estate needs will look like in the future, and along the way, questions that go back to what Bhushan and Nada were talking about, I think are emerging for them. They're asking about energy efficiency, actually, although it's not their mission. I work otherwise on the ways in which political power is being redistributed among governments, people, and corporations, and that is actually very exciting for me.
Very fascinating. Thank you so much, Amy. And Dr. Lee, so Clara, so your work at Intel, and you have different roles and responsibilities there as well. Could you help us to understand what you're working on these days and what excites you?
Yes, so my role in Intel is mainly on developing the wireless standards. So we have been working on 4G, 5G, and now on 6G. So when we do standards, it's typically standards are developed beforehand the product development and commercialization. So we need to have a good kind of prediction on what's needed, for example, 10 years down the road. So therefore, now we are at the stage of the 6G technology development, and eventually we'll go to standardization. So we do need to see what do we need to incorporate in 6G in order to meet our requirements, of the society and the industry, let's say in 10 years. So therefore, sustainability is really becoming one of the prime goal for 6G, which I say is really different from previous generations. Now we have sustainability as one of the primary goals from the beginning of 6G development, so that we can help the society and the industry to really achieving the net zero target. Yeah, so this is my role. Yeah.
No, yeah, great. Thank you so much, Dr. Lee. And so let me follow up on this one. And as we've heard, from the keynote speaker as well from Wujan about the 6G white paper we have issued. So Clara, so how do you see the role of 6G in terms of achieving net zero? So where do you see the priorities lie, and how do you see this unfold?
Yeah, I think we need to consider this from two aspects. One aspect is 6G itself need to be energy efficient and sustainable. So sustainability need to be baked in throughout the life cycle of 6G, from system design to implementation to commercialization. So in the whole life cycle, we need to ensure sustainability. And another aspect is for 6G to help the society and the industry to better achieving their net zero goals. So technology advances in 6G, for example, on communication, on computing, and on data, are expected to help the society and the industries to improve efficiency. So that the world as a whole, together, we can achieve a good balance on consumption and conservation. So yeah, so those are the two aspects that 6G would bring in. Yeah.
Great. Amy, this leads me I want to ask you about, so let's assume this whole technology is in place, right? So and whatever challenges are associated with that, but what kind of other elements are critical to create the conditions that actually allow consumers and manufacturers to adopt and implement sustainability actions?
I think that I would give almost one answer, and it has to do with story or narrative. We really need to have holistically an understanding, a cultural shift, right? In the stories that generate behaviors and model ways of thinking. We live in story. So Nada talked, for example, that may sound very abstract, or do you just mean sort of marketing? But Nada talked, for example, about the need to manage this paradox between increasing available connectivity leading generally to an increase in consumption. So we need to think, and that, for me, when I think about it, goes deeply, deeply to myths that we hold that don't have to do with technology about what abundance looks like, what progress looks like. So we need to sort of retool our shared deep myths about how we behave in a world that is sustainable, good, abundant, and so forth. That helps consumers, but also actually prods, because consumers are so deeply important because of how influential we are right now, not so much because of the actions we take, picking up our litter or so forth. But we can influence then manufacturers and governments once we share a narrative. The other thing that a narrative can do, or narratives about sustainability, is they can appropriately align or realign incentives so that they model ways that good technology firms, good governments, good people, good communities behave. And so I think my answer is we need great stories.
Okay, very good. Well, I like the fact that, once we talk about technology and other things in a story, people can actually more likely relate to this. You spoke about this narrative, the narrative about sustainability and the retooling of the behavior. So I wanted to ask Andrea, so how can you or we motivate the private and public sector to actually create value? Telling the story it's great, and I think it's important, but at the same time, we have to have some value. And I think as the environmental economist, maybe you can help us to better understand what we need to do to motivate the private and public sector.
Sure. So the idea of organizational or corporate sustainability is creating shared value for the businesses, the stakeholders, and the social context in which it operates. So companies and organizations can start by taking advantage of the low-hanging fruit, which are processes, methods, or materials that reduce overhead while also improving the community and or the environmental impact. As an entity progresses down this path beyond cost-saving measures, it's important to understand the value of actions. This is where the monetization of economic, social, and environmental goods and services, or the triple bottom line, can be useful for understanding the real value of those investments in sustainability. And not everything can be monetized, right? But you can also consider it qualitatively. So it's important to really have that broad understanding of your impacts.
Very good. All right. And by the way, for the audience, I love the questions that are coming in. So please keep them going so that, at the end of our panel, we'll have some time to kind of address those. So please keep the questions going. Amy, most people there are not engineers, right? Or don't necessarily have a deep technical understanding. So what kind of human demands must be considered to kind of foster a broader adoption of innovations such as 6G?
Right. Network dependability, equitable access, capacity to participate in the distribution of goods that come via digital means, whether that's information or education, or the opportunity to work. 6G needs to be affordable. So a lot of the answers that you would apply to 5G as well, and to different parts of the country and society. I would add to this digital literacy for everyone. I mean, your point that I actually do think that everyone in the audience today might be an engineer, because I'm looking at the questions coming in, but most of us are not engineers. And as we get more entwined with machines, as they, also become partners for us, I think it's really important for individuals and for people in business, in their professional roles, to have a fairly decent understanding of what a network is, what happens when you press send on an email. I mean, to really kind of just have this be part of our education, and part of this goes back to trust. There are some really dire things, which probably everyone here is familiar with, about 5G and COVID. Sort of very paranoid perceptions can arise that entangle, networks and their providers and so forth, and they're toxic. So literacy might go some way toward helping us appreciate the opportunity to broadly adopt 6G.
Okay, so do you see that people, consumers, that there's an awareness campaign necessary for that matter, or how do you see that, Amy?
That's interesting. I don't have a pre-cooked answer. I mean, I think that the way that most individual consumers become aware of anything like 5G and 6G without knowing it's a protocol, without knowing what the 6 is and the 5 is or the G is probably through their purchases of cell phones. And suddenly you're told that you have a phone with a capacity that you didn't know what it was. So yeah, I think it would be useful for, secondary school students to understand what a network looks like, and where there are sensors and distributors and connectors, and how it works. I mean, we maybe used to learn about radios and radio frequencies and electronics. We should be learning this stuff too.
Yeah, okay. Great. Andrea, so the technology itself, right? The benefits, the work that needs to be done. When we look at there must be risks associated with every kind of element. And when we look at the risk from an organization's perspective and companies, so in their pursuit towards sustainability, as it relates to innovation. So what risks do you actually see that need to be addressed, and we need to educate and provide information in order to overcome those and solve those?
So we're already starting to see we're already starting to witness the damaging effects of climate change. So one of the top risks to companies are supply chain interruptions due to extreme weather events. Companies are responding by diversifying their material inputs and products and operations, and geographically diversifying their workforce and operations. There's an impending need to adapt and build resilience, in addition to pressure from investors on companies to increase their sustainability efforts. And just this past Monday, the SEC issued a proposed rule that would mandate specific disclosures on greenhouse gas emissions and associated climate change risks by all publicly traded companies. Technology and innovation are seen as the keys to enabling new business models for industry-wide decarbonization. However, we need effective data management across the value chain and affordability.
All right, okay. So I think, there's definitely what appears to be more work needs to be done, right, in the deployment and in the use of innovation. I want to ask Clara, so in terms of like the risks, we just talked about the economic value, the digital literacy, what priorities and urgencies do you see that need to be addressed in terms of like how can 6G do it differently compared to 4G and 5G? What do you see where the priorities and urgencies are?
Yes. So today we are facing more and more kind of impact on climate change and extreme weather conditions and increased temperature. They are affecting the everyday life of ours. So there is an urgent need of achieving sustainability goals. So we expect the 6G as the first generation, then to make sustainability as one of the prime design goals. So for instance, in electric lines, we know that sustainability is regarded as one of the 6G audacious goals. So this would allow 6G to take a thorough look at the sustainability from the very beginning of the system design. So there are many things we need to consider, we need to do, as we already heard a lot from our previous speakers. And just a few things I want to highlight. So one thing is we need to define a proper performance matrix and make sustainability measurable. And another thing is we need to identify what are the main factors that lead to high energy consumption so that we can address those accordingly. And more importantly, I think we need to take a holistic view on the system and look for overall system efficiency and avoid local optimization while missing the big picture. So I think in general, we need to consider sustainability at the beginning of the 6G system design, and consider this as and look at 6G system as altogether as a whole, and try to address the sustainability from the overall system perspective, while also considering the individual components.
Okay, that's very interesting. Thank you so much for sharing your insights on that one. So we got a question from the audience I would like to address, and I'll leave this up to you to chime in. So do you think that making 6G truly more sustainable compared to a 4G and 5G, is that sufficient to entice the industry and the consumers to adopt it? Anybody wants to take that on? Is just being more sustainable or truly more sustainable sufficient that people will like, okay, I'm gonna truly embrace 6G? Is that enough? And what else may need to be done? Who wants to take this on?
So, do you want to go ahead, Clara?
No, go ahead.
Okay. Sorry. So I don't know that if it's talking about users adopting, I think, eventually, just like with every next G, we all eventually adopt it. I don't know that users are necessarily deciding whether they want to adopt it or not. But as far as consumer choice, obviously we always want faster and better and all of that. But I think companies have an opportunity to really get a competitive advantage and distinguish themselves, and let the consumers know if they're buying a product, how does this compare to another product? If they're taking more sustainable actions and this is a more sustainable product, if they're, instead of using rare earth minerals, maybe they're using something that's renewable, and maybe they have a much better program for recycling your used products and reusing them. And so I think in that regard, I think companies have an opportunity here to really distinguish themselves and get a competitive edge.
Okay. Clara, you wanted to mention as well something to that extent?
Yes, just to add something. I think consumers today are getting more and more aware on the sustainability, on what are the carbon footprints when they buy stuff. So I know in some parts of the world they even introduce the carbon label. So when people buy something, they can check what is the carbon footprint of that thing that they buy. So I think similarly, when we introduce 6G as technology, we also need to be very aware, and also to give the users a sense of how energy efficient it is and what is carbon footprint it could be. And also another aspect is it's not only a 6G its own design problem, but it's also we also want to try to make 6G as a tool for the other industries and all other aspects of society to use to achieve kind of overall carbon neutrality go together. So we also need to strike a good balance between consumption and conservation. So yeah.
Very good. Thank you for that insight. Amy, because on a light note, it's Friday and we have a question here from the audience, and I know you adopted a baby, right? Which is now 7 months old, and you have your hands full. You shared this with us. So in terms of like educating our children, right? So here's a question from the audience, in terms of sustainability and the use of network technology. Do you think we should advise our teenagers don't send cute cat pictures on TikTok?
Well, good luck. I mean, I'm only, as you point out, at 7 months, but I think they're strong-willed creatures, these children. As a sustainability issue, I deal a lot with digital rights. So on a lighter note, I think whatever works for you and your household, you should do. I'm going to stick with good luck.
Okay. Very good. All right, thank you so much. So look, so what I'm going to do, so to wrap this up, as we're running out of time here, so we have to have a sort of call to action, right? So what's coming next, right? So we have this webinar today, right? We have the white paper has been issued. So do you think we're doing enough, and what must we do today and tomorrow moving forward in terms of the sense of urgency, for motivating organizations, the government, and consumers, So how do you see that? What needs to be done today and tomorrow? And I would, starting with you, Andrea.
I think as we saw, I believe it was Bhushan's presentation, we're at 1.2 degrees of warming. IPCC has warned we don't want to get beyond 1.5. We need to make change yesterday, actually, not today. we're behind. So really, we need to take more aggressive actions now, because we haven't taken as aggressive of actions for the last couple of decades. And so I think companies starting to look within internally about how they can design more sustainable, looking at their operations, what they can do to make reduce, their energy and water and land use. And so really, I think each company taking steps, as well as individuals. We can all do something individually to make a difference. And so, I think it's imperative that we start making change.
Okay, start making change. Dr. Lee, Clara, what are your thoughts?
Yeah, I want to echo Andrea. So I think it's never too early. It's never too early to start to act. So I think it's the mission of our generation to really achieve the sustainable growth of the whole world. So every sectors of the of the world, industry, government, academia. So every sectors need to start to act and think about what we can do to help achieve the sustainability goals of this of our world. Yeah.
Very good. Amy, final thoughts in terms of how can we come together and what can we do today and tomorrow?
Yeah, I think the issue is actually scale. Like lots of good efforts, including the one that we're sort of speaking on behalf of, are unfolding, but not at I'll call it speed and scale. So Clara listed like a great series of questions that the tech industry in particular should be asking about how to build sustainability into its hardware and into networks. I think that conversation should be happening, everywhere. That's foresight. That needs to become a part of doing business. It should not be a sort of nice set of questions to ask. Similarly, Andrea's answer to the question about a previous question about sort of what should be done was really interesting, because you listed kind of a push right now of sustainability to consumers and to companies, like that, we should let them know this is a competitive advantage. There's another step where this becomes a pull. It's not a competitive advantage, it's a necessity, like a good price. We must grow into a space, and that's where narrative comes in. It's not that we tell a story about something, it's that we don't even think about it. It's in our worldview, the same way that we look for a good bargain or what have you. We need sustainability because we understand that that's just part of the way that good products and good services come. So the more of this that's done, the more we scale, like the better.
All right, very good. So I think we have the narrative about sustainability. Let's keep building the story, and let's just make the story come true, right? So with that, I would really like to thank, first of all, the audience for all the great questions. We only had very limited time to address them, but thank you so much for your participation. I would like to thank the Green G, our working group, to bring sustainability to the forefront of the conversation. And I would love to thank you, Andrea, Amy, and Clara, for being on this panel and sharing your insights with us today. So I really, really appreciate that. I wish you have a wonderful rest of the Friday and a great weekend. With that, I would like to hand it over to Mikaela Judah from Microsoft, our Green G co-chair, for the final remarks.
Thank you very much, Carsten. And I would like to just take the opportunity to thank the remarkable speakers in this webinar and their contribution, the fact that they spent some time, and also I would like to thank the audience for participating. Due to the time remaining and constraints, I would like to just highlight a few things that I thought they were very important. One, the fact that Nada talked about consumption increase, and the fact that I've just heard the notion of data sobriety makes us think about how much we need to consume actually, and what it's worth consuming. Bhushan had an exceptional overview of the white paper, and I think talking about the ROI, it's very important, and I would like to end with that, but I'll put that aside for a moment. Amy talked about the future, and it's absolutely fascinating. Clara talking about the need to measure, and again, something that is extremely important, as well as the competitive advantage that Andrea mentioned. I thought they were all fantastic points that are, giving us thought and sort of strength to go forward on this sustainability road. We do need data, we need insights, and we need to take action. But it's more than that. If we look at the economic data, sustainability measures present incredible economic and market opportunities. Bold climate action could deliver at least $26 trillion in economic benefits through 2030. It could also produce over 65 million new low carbon jobs. Governments globally are expected to spend up to $60 billion on energy efficiency technologies and investments by 2028. And the value of the global market for carbon emissions offsets could be worth $200 billion by 2050. So as I conclude and thank everyone for their participation, I would like to remind everyone as well that sustainability is really great for business. Thank you very much.